Given 2 points, A and B, the line segment AB is rotated counterclockwise by 15 degrees around point A. Determine the equation of the line in its new position. Additionally, if point B moves to point C after the rotation, what will be the coordinates of the point C? Okay, let us begin. First, let's try to understand the problem graphically. So here we have the xy coordinate axis and we have the line L. Now let's say the line passes through 2 points A and B. Now clearly the y coordinate of point A is 0, so that means it's going to lie on the x-axis. So let's say this is the point A with the coordinates 2, 0. Let's take another point on the line with the coordinates 3, 1. Right. Now clearly this particular figure is not drawn to scale. Okay. So here we have the 2 points A and B through which the line passes. Now what we are going to do is we are going to rotate this line about the point A by 15 degrees in the anti-clockwise fashion. So let's say after rotation, so we have rotated this line by 15 degrees and this gives us a new line. We're going to call it L prime, and B, the point B changes to a new point. Let's call it the point C. And we're going to assume that it has the coordinates x, y. Our goal will be to determine the coordinates of the point C as well. Okay, so there are two things that we need to do. We need to determine the equation of the line L prime as well as the coordinates of the point C. Okay, so how shall we approach this problem? Now clearly, what we can do here is we can use the distance form of a line. We know that the distance form of a line is given by, let's say, let us consider that x minus x1 divided by cosine of alpha equals to y minus y1 divided by sine of alpha. So let's say this is equals to r, be the equation of the line. So this is referred to as the distance form of a line. So this is the equation of a line, the line whose equation we need to determine. Now clearly this particular equation tells us that we have 2 points through which the line passes. One of the point is going to be x, y, and the other line is going to be x1, y1. However, when we are writing this particular equation, we have to make sure that the point x, y lies to the right of x1, y1. So you can check out the proof part to understand the position of these points, which needs to be taken first and which needs to be taken later. Okay, now coming to the point, what is alpha here? Alpha is the angle that the straight line is going to make with the positive direction of x-axis. So that means if we consider the line L, then in that case, so here we can say this angle is, if we call it theta, then theta is the angle that the line L makes with the positive direction of x-axis. But in our problem, what we need here is alpha here. So alpha is actually going to be theta added to 15 degrees because we want to obtain the equation of L prime. So here, equation of the line, let's call it L prime. That's what we need to obtain. So here we need alpha. So alpha must be equals to theta plus 15 degree. So what we'll need to do here, we'll need to obtain the value of alpha. So how shall we do that? That's a very simple task. So what we know that since theta is the angle made by the line L with the positive direction of x-axis, so here we can say if we take tangent of angle theta, the tangent of the angle theta, that is simply equals to the slope of the line, the original line L. And since we have the line passing through 2 points A and B, we can easily find out the slope of that line. So here, let's start. So we'll need a ratio. In the numerator, we'll take the difference of the x coordinate. So we have 1 minus difference of the y coordinate. So we have 1 minus 0. And then in the denominator, we need the difference of the x coordinate. So that's 3 minus 2. And that's going to give us 1, which means that tangent of theta equals to 1. Now, when is the angle tangent of some angle equals to 1? That's when the theta value equals to 45 degrees. So here we have obtained the angle that the line L makes with the positive direction of x-axis. So theta comes out to be equals to 45 degree. Now if theta is 45 degree, then what is going to be the value of alpha? So this is, let me use a different color here. So this is going to be the angle alpha. Fine. So now we can say that alpha value, so that is going to be given by, we know it's theta plus 15 degree. So since theta is 45 degrees, so we're 45 added to 15 degree, and this is going to be equals to 60 degree. Now that means the line L prime, so after being rotated by a 15 degree from the initial position, I mean about A, then alpha comes out to be equals to 60 degrees. So we have one information. Now using this, what we get, other information that we need is R. So what is R here? R is going to be the distance between the 2 points through which the line passes. So that means if we consider the line L, then AB is going to be equivalent to R. So AB is going to be equals to R. Now after rotation, we get the new line L prime. So in this case, AC is going to be equals to R. So we need to obtain R because this R actually corresponds to the length AC. Okay, now clearly AC here is going to be exactly the same as AB. There will no be change in the length. Okay, so what we can do, we can use the distance formula to find out the length of AB. So using the distance formula, so the length of AB, so that is going to be given by, we'll take the square root. Underneath the square root, we need d square of the difference of the x coordinates. So we'll take 3 minus 2, square this value, and then add it to the square of the difference of the y coordinate. So y coordinate difference will be 1 minus 0, and solving this gives us square root of 2. So AB comes out to be square root of 2. In other words, we can say R value that's equals to square root of 2, which is also equals to the value of AC. So now we have obtained the value of alpha. We have the value of R, that is square root of 2. We're ready to find out the equation of the line using the distance form. Okay. So let us find out the equation of the new line L prime. Okay, so what we need is the difference of the x coordinate. Now here, in the line L prime, we see that x comma y lies to the right of the point A. Or in other words, we can say that the x and the y coordinate of point A is greater than the x and the y coordinate of point A. So here what we'll do, we're going to take x minus 2 divided by cosine of the angle alpha. Alpha came out to be 60 degrees. That's equals to, we take the difference, y minus 0 divided by sine 60 degrees. And this is going to be equals to the distance between the point A and C, which is R, and R came out to be square root of 2. Okay, so here we have x minus 2 divided by cosine 60 degree. So cosine of 60 degree, that simply equals to 1/2. This is going to be equals to y divided by sine 60. So that's square root of 3 over 2, and that's equals to square root of 2. Fine. Now, if we want to find out the equation of the line, we only have to consider the first two part of the ratio. So here we can say that x minus 2 divided by 1/2 equals to y over square root of 3 over 2. So solving this, we're going to get x minus 2 equals to y over square root of 3. And let's multiply throughout with square root of 3. So we'll get square root of 3x. Then we have negative y equals to 2 times square root of 3. So this is the equation of the line L prime. So we've obtained the equation of the line L prime. We also need to obtain the coordinates of the point C. Now to find out the coordinates of the point C, again we can take help of this equation. So here what we can do, we'll take x minus 2 over 1/2 and equate it to square root of 2. So that means we have x minus 2 equals to square root of 2 divided by 2. Solving for x, we get x equals to 2 added to square root of 2 divided by 2. And we have y divided by square root of 3 over 2. That is going to be equals to square root of 2. So y is going to be equals to square root of 6 over 2. So we've obtained the coordinates of the point as well. So x comma y, which is going to be the coordinates of the point C. That is the same as the x coordinate value, which is 2 plus square root of 2 over 2, and the y coordinate value, that's square root of 6 over 2. So here we have successfully obtained the equation of the line L prime as well as the coordinates of the point C, which is actually the coordinates of the point P in its new position when the line is rotated 15 degrees about the point A in the anti-clockwise fashion.